Hi everyone, this video is just a quick introduction to the next set of topics you're going to be learning. The next set involves radicals, which is just a different name for roots. So here are some things that you're probably familiar with already. Things like the square root of 25 is 5. That's because 5 times 5, or 5 squared, is 25. Square root of 81 is 9. Same reason. 9 squared is 81. We also will study some different types of roots, like cube roots. Cube root of 8 is 2, because 2 to the third power is 8. And cube root of negative 1, we'll talk about when you're allowed to have a negative underneath the root. In this case, because it's a cube root, the cube root of negative 1 is negative 1, because negative 1 to the third power is negative 1. If you have square roots, we'll talk about what happens when you have a negative underneath the square root, but that's some of the topic to come. After that, you'll talk about simplifying square roots. If you play around with your calculator a little bit, you might notice that if you take the square root of a big number, you'll get a decimal, like the square root of 48 is 6.9282, about, that's rounded. You'll also get the exact same thing if you type in 4 times the square root of 3. So this one's considered the simplified form of this, and we'll talk about how to go from one to the other. And we'll also talk about what to do with variables when you have variables underneath the root. After we do that, we'll talk about some graphs, because you know this class has a lot of graphing in it. And the shape of a square root graph is what we call a hook-shaped graph. It has an endpoint right here, and that kind of hooks off in one direction. Sometimes they go in the other direction, but this one hooks to the right. And this endpoint right here, turns out, is tied directly to the stuff that's underneath the radical, and you'll see the connection between that. And so we'll talk about the domain and range of these functions, which has to do with the stuff underneath the radical, also called the radicand. And then we'll finish up the chapter with solving some equations, both by hand, using algebraic techniques, and with a graph. So here's an example of an equation that has a root in it. Sometimes you might have roots on both sides, sometimes just one side. So square root of x plus 3 equals x minus 1. We'll talk about how to do it by hand and with a graph. And even though you haven't even been through the chapter yet, you actually probably know how to do it with a graph. You can just graph the left side of the function, which will be that hook-shaped graph that I just showed you. You can graph the right side of the function, and you'll do that with your graphing calculator or with Desmos. And that one it's going to turn out will be a straight line, kind of going, ooh, that's not so straight, but you get the idea there. And just like everything else we've studied, the solution comes from the point of intersection, the x-coordinate of the point of intersection. So there's your overview of the next set of topics, and we'll see you online.